Question 21 says, 4 conductors each carrying current of 3 ampere and a closed loop are shown in the figure. The line integral within bracket circulation of magnetic field produced by all 4 wires along the indicated closed loop is equal to. So we simply apply Ampere's circuital law. We can see that the net current enclosed within the loop will be 3 ampere only, because 3 ampere and 3 ampere, they are coming out and 3 ampere is going in. So the net current enclosed is 3 ampere which is coming out, and since the direction of arrow is clockwise, the circulation will be negative. So if we apply Ampere's circuital law, it says circulation of magnetic field B around a closed loop is mu naught times current enclosed. In this case, current enclosed will be effectively minus 3 ampere. So our answer is option 3, because the circulation of field is minus mu naught 3. So option 3 is correct. Let's go to question 22 now. Question 22 says, if at t equal to 0, switch K is closed, and at t equal to t naught, charge on the capacitor becomes 80 microcoulomb, then value of t naught is, and given CE is 240 microcoulomb. So we have been given this RC circuit. So we find the effective time constant, and for effective time constant we find effective resistance across the 2 plates by replacing the cell by a connecting wire. So if we do that, this 2R and this R, they are in parallel. So their equivalent is 2R by 3, and that in series with R will give us 2R by 3 plus R, which is 5R by 3. This will be R effective, and so time constant is 5RC by 3. Also, the final charge on the capacitor will be, the final potential difference across the capacitor will be 2R. V final is going to be equal to 2R divided by E by 3R, or 2E by 3, which means the final charge is 2EC by 3. So Q at time t can be written as final charge, value of final charge is 2C by 3, that means 2 by 3 of 240, that is 160 microcoulomb. So it's 160 microcoulomb into 1 minus e to the power minus t by tau. Now Q is 80 microcoulomb. If we put that, we get 1 by 2 is equal to e to the power minus t by tau, which means ln2 equal to t by tau, or t, which is t naught, is equal to tau ln2. That means 5RC by 3 ln2, which is matching with option 3. So option 3 is correct. Let's go to question 23 now. Consider the shown circuit. If each battery has 0 internal resistance, then potential difference across point C and D is. This is a simple circuit. The upper branch has effective resistance of 4 plus 4, 8 ohm, and the lower branch also has effective resistance of 8 ohm. So we can straight away write the current. Current here is 12 volt is the EMF, 12 volt divided by 8 ohm, that means 1.5 ampere. And in the upper branch also it is 1.5 ampere. So if we start from C, VC minus 1.5 into 4, that is 6, plus 1.5 into 3, that is 4.5, is equal to VD, and which means VC minus VD is 1.5 volt, which matches with option 3. Let's go to question 24 now. Question 24 says equivalent resistance between point A and B for the circuit shown in the figure is equal to. So in this figure we can see that potential of this point is same as potential of A, so this is also we can put it as A, and similarly this point has same potential as that of B. so we can put it as B only. We can see that all the three resistors are connected between A and B. So they are all in parallel, and 3 ohm and 3 ohm and 3 ohm in parallel will give us 1 ohm. Option 2 is correct. Let's go to question 25 now. Question 25 says, for electromagnet the core should have, this is a theoretical question. We know for electromagnet the core should have low retentivity and low coercivity, which is matching with option 4. So option 4 is correct. Let's go to question 26 now.